Welcome to The Explainer. Today we're tackling a really interesting question. Why can a brand new, super powerful computer still feel sluggish sometimes? Well, the secret isn't always the processor. It's actually hidden in the data highways that connect everything inside your machine and how they can create a system-wide traffic jam.
So, let's start with a puzzle. You can have the fastest, most powerful CPU in the world, an engine that's capable of just incredible things. But here's the catch. It's only one part of a much bigger team. And, a team is only as fast as its members can communicate. If data can't get to and from that powerful engine fast enough, you end up with a huge bottleneck, a system-wide traffic jam.
The key to clearing these traffic jams is a component you've probably never even thought about, the computer bus. It's really the unsung hero of your computer's performance, the hidden data highway that makes everything else you do possible.
So what is a bus? Well, it's quite literally the data highway system inside your machine. It's a set of electrical pathways that connects all the big components, the CPU, your memory, your graphics card, all of it. And just like a real highway, the more lanes it has, we call that the bus width, and the higher the speed limit, the bus speed, the more data can move at once. Simple, right?
But, in the early days of PCs, these so-called data highways, they were more like bumpy country roads. They were slow, they got congested really easily, and they very quickly became the single biggest thing holding back computer performance.
Yeah, if you look at the timeline, you can see these first attempts just crawled along. You had the EISA bus back in the 80s, which was standard, but its 8 MHz speed limit was painful. The first fix, EISA, was basically just adding more lanes to the same slow road. Then you had the VESA bus, which was kind of like a special express lane just for video, but it couldn't solve the core traffic problem for the rest of the system.
This table really puts the problem into perspective. You can see the throughput, that's the actual flow of traffic, just barely creeping up. But even the fastest option here, the VO bus, was a total dead end. Processors were getting exponentially faster, and 132 megabytes per second just wasn't going to cut it. That old country road just could not handle the supercars that were starting to show up. So it was crystal clear that these little piecemeal upgrades just weren't working. The industry had to stop patching up the old roads and build a brand new, unified superhighway for everybody. And this led to a massive breakthrough in 1992.
So, in what was a pretty rare move, all these major tech competitors actually got together. They formed something called the PCI Special Interest Group, or PCI-SIG, with one simple goal: build a universal standard to solve this bottleneck problem for good. And their creation was the revolutionary PCI bus. PCI, which stands for Peripheral Component Interconnect, was an absolute game changer. I mean, yes, it was faster, but more importantly, it was so much smarter. It introduced plug-and-play, and it's honestly hard to overstate how huge this was. For the first time, you could just plug a new part into your PC, and it would just work. No more flipping tiny switches or manual setups. This feature, right here, is what made upgrading a PC something an average person could actually do. And right out of the gate, the very first version of PCI matched the absolute top speed of that old VESA bus, 133 megabytes per second. But the key thing is, this was now the new starting line, and it was a standard that could apply to every single component, not just video.
But see, PCI was designed to grow. By doubling the number of lanes and doubling the speed limit, the performance didn't just double, it quadrupled. All of a sudden, the throughput was over 500 megabytes per second. The new superhighway was officially open for business and could finally handle some serious traffic.
Of course, the demand for speed never ever stops, especially not in the world of high-end servers and professional workstations. For these power users, the ones who needed even more performance, engineers developed an evolution of PCI called PCI-X. PCI-X was a really clever design. Think of it like adding an express toll lane to that existing PCI highway. It was fully backwards compatible, so all your old PCI cards still worked perfectly fine, but it was built for much, much higher speeds, specifically for things like giant storage networks and super fast data transfers.
But even this supercharged highway had one fatal flaw. It was a shared highway. Every single device used the same road. And just like in real traffic, if one slow car gets on, everybody behind it has to slow down. It didn't matter how fast your brand new graphics card was if your old network card was slowing down the entire bus. This was the final bottleneck that had to be overcome.
So to finally break free from this slowest device problem, the next evolution couldn't just be a faster highway. No, it required a complete redesign of the entire transportation system. And that brings us to PCI Express.
Okay, so let's really dive into this because this is the truly revolutionary part. PCI Express, or PCIe, completely threw out the old shared highway model. Instead, it gives every single component its own private, dedicated, point-to-point express lane directly to the system's data hub. That means a slow device over in one lane has absolutely zero impact on a fast device in another.
And this chart, wow. This just shows you what a mind-boggling leap in performance this was. Just look at that jump. A single PCIe slot for a modern graphics card, that's that bar on the far right, offers a throughput that completely dwarfs everything that came before it. This wasn't just an improvement, it was a total paradigm shift.
So, after all this technical history, what does this whole quest for speed actually mean for you today using your computer? What does any of this stuff really matter?
Well, this table really says it all. You can see the absolutely exponential growth, from a measly 16 megabytes per second with EISA all the way to 8,000 with just the first generation of PCI. And you'll notice the speed unit for PCI actually changes from megahertz to GT/S. That's gigatransfers per second. That's because the new design is so different that its raw speed is measured in a totally new way. But the end result is a staggering 500-fold increase in bandwidth. This massive bandwidth is what makes our modern computing experience possible. It's what allows your graphics card to render these incredibly complex 3D worlds without stuttering. It's what lets you transfer gigabytes of data from a super fast SSD in just a few seconds. It's what makes sure every part of your computer can work at its absolute full potential without ever causing that dreaded system-wide traffic jam.
This whole journey, right, from slow country roads to multi-lane superhighways and now to private express lanes, has really been about just one thing: finding and eliminating bottlenecks. And as our technologies like AI, virtual reality, and even faster storage keep advancing, our demand for data seems completely endless. Which really makes you wonder, what will the next generation of data superhighways even need to look like to keep up with all of that?